In this video, we're going to see what are associative property on rational numbers. So first, to begin with, let's quickly see what exactly are rational numbers. Rational numbers are any number which can be expressed in the form of p by q, okay, where p is any integer. Let me write it down. Where p is any integer and q is also any integer except 0, okay. Q is any integer except 0, okay. So this is our quick revision of what are rational numbers. Rational numbers are numbers which can be expressed in the form p by q, where p is any integer and q is also an integer other than 0. Now, in order to understand the associative property on rational numbers, the first mathematical operation that we are going to take is addition. So let's see, when we use the operation addition on certain rational numbers, how do they behave. So here I have noted down three random rational numbers to take for our example. Let's zoom in. Okay, so this is our example. This is rational number. Let me zoom out to make my statements. So this 1 by 2 is a rational number. Yes, it is of the form p by q. 3 by 4 is a rational number. Yes, it is of the form p by q. And 5 by 3 is a rational number. Yes, it is also of the form p by q. So thus we have three rational numbers, and now we are going to focus on the operation addition. So I'm going to insert the operation addition in these three numbers. So this is plus and this is plus. Now we are checking associative property on rational numbers, which basically means that we can associate these numbers in two different ways and solve this entire expression. The first way is where I club 1 by 2 and 3 by 4 together. So I'll put a bracket around it, and then I will do plus 5 by 3. And the second way is I will keep 1 by 2 outside and I will club 3 by 4 and 5 by 3 together. So I'll put a bracket around them. Okay, so once again, let's just have a quick look. This was our expression. We were adding three rational numbers. Now there are two ways in which three rational numbers can be added. We can add these two first and then add the last one, or we can add the second and third first and then add the first one. So brackets denote associativity, how we are going to associate these rational numbers. Now let's solve each of these expression individually. So first I'm going to solve 1 by 2 plus 3 by 4. So that is 1 into 4, 4 plus 2 into 3 is 6. The whole divided by 2 into 4 is 8. So this remains as bracket, plus 5 by 3. That is equal to 4 plus 6 is 10. The whole divided by 8 and plus 5 by 3. So we continue with our addition. So 10 into 3 is 30 plus 8 into 5 is 40. The whole divided by 8 into 3, which is 24. Okay, we know how to add two rational numbers, and now that is equal to 70 divided by 24. So this is my answer when I'm solving this example. Okay, when I'm solving this example by associating first two rational numbers. Now let's go this way, where we associate second and third rational numbers first. So this is equal to 1 by 2 plus, so 3 into 3 9 plus 4 into 5 20. The whole divided by 4 3s are 12. Okay, so that is equal to 1 by 2 plus 9 plus 20 is 29. The whole divided by 12. And now that is again equal to 1 into 12 is 12 plus 29 into 2 is 58. Okay, the whole divided by 2 into 12 is 24, and that is equal to 70 divided by 24, which is exactly same as the previous output, 70 by 24, 70 by 24. Thus we see that in this example we took three rational numbers, we associated them in two different ways, and we still got the same output. And hence we come to the conclusion, this is the conclusion that we have noted down, and hence we come to the conclusion that addition is associative. Addition operation, the operation addition on rational numbers is associative, which means that the way you associate the numbers while doing addition does not matter. The result is same. So we note it down in words. That is, for any three rational numbers a, b and c. Now I'm going to write the statement. For any three rational numbers a, b and c, a plus b plus c, where I associate these two first, is equal to a plus b plus c, where I associate these two first. Okay, so for any three rational numbers, the way we associate them does not matter. So this was our associative property on rational numbers for the operation addition. Now very similarly, we do the exact same procedure for the operation of subtraction. So here I'm going to be a little bit faster. Okay, again I have taken the example, same three numbers we have, 1 by 2, 3 by 4, 5 by 3, and they are our rational numbers. So we start with doing this, inserting this minus operation in between them. Now once again, there are two ways to do it. One is I will do 1 by 2 minus 3 by 4 first, so I'm going to club them, and then I'm going to do minus 5 by 3, and the other one is 1 by 2 minus, I'm going to club the second and third rational number, 3 by 4 minus 5 by 3. Okay, let's quickly do them. So 1 by 2, it's 1 into 4, 4, minus 2 into 3, 6, the whole upon 2 4s are 8. Okay, this is the bracket, minus 5 by 3. So 4 minus 6 is minus 2 upon 8 minus 5 by 3. Okay, so now here once again we have minus 2 into 3, that is minus 6, minus 5 8s are 40, the whole upon 8 3s are 24, and that is equal to minus 46, the whole divided by 24. This is the answer of our left hand side, the way we associated the first and second. Now here we have associated second and third rational number. Let's see what the outcome comes. Now this is equal to 1 by 2 minus, so 3 into 3 9, minus 5 4s are 20, the whole divided by 12. Okay, that is equal to 1 by 2 minus 9 minus 20 is minus 11, the whole upon 12. Okay, now this minus and this minus becomes plus, so that becomes 1 by 2 plus 11 by 12, and that is equal to 12 into 1 is 12 plus 11 2s are 22, the whole divided by 2 into 12 is 24, and that is equal to 2 plus 2 4, and 2 and 1 3. So we got 34 divided by 24. Now you can note down that this output 34 by 24 is different than minus 46 by 24. Thus we can conclude that when we associate the numbers in different ways for the operation of subtraction, the output is not same, and thus we say that when it comes to subtraction, it is not associative. Okay, so subtraction is not associative for rational numbers, that is for any three rational numbers a, b and c. Let's complete this statement. For any three rational numbers a, b and c, a minus b minus c, where I associate these two first, is not equal to a minus b minus c, where I associate these two first. Okay, so this association is not equal, so subtraction is not associative. Again, very similarly and very quickly, we go to the operation of multiplication. Again, for the rational numbers, I have noted down an example. Same three rational numbers, 1 by 2, 3 by 4, 5 by 3. Note that you can take any random rational number of the form p by q, okay, of this form p by q, and you can do this simple testing. I am going with these three rational numbers. So our operation is multiplication. Let me first insert the operation of multiplication in these three. Now again, there are two ways to solve this. I can associate 1 by 2 and 3 by 4 first. Here I associate them, and then I will do 5 by 3, or I can do 1 by 2 into, I will do 3 by 4 into 5 by 3 first, and this is how I'm going to associate them. Okay, so let's go with our left hand side. 1 by 2 into 3 by 4. So as we know, in multiplication it's 1 into 3. Okay, so 1 into 3 is 3, and 2 into 4 is 8, into 5 by 3, and that is equal to 5 3s are 15 upon 8 3s are 24. The multiplication is very simple, very quick. We just multiply the numerators and the denominators. So the answer we get is 15 by 24. Now next we come here. This is equal to 1 by 2 into, again 3 into 5 is 15, and 4 into 3 is 12. Okay, and once again we just multiply the numerators. 1 into 15 is 15, and 2 into 12 is 24. So as you can see, here I have got 15 by 24, here I have got 15 by 24. So when it comes to multiplication of rational numbers, the way we associate the numbers, either first two or the last two, does not matter. The output is going to be the same, and thus we say that multiplication operation, the operation multiplication on rational numbers, is associative. That's what we have noted down in our conclusion. Okay, so here it is. Multiplication is associative, that is for any three rational numbers a, b and c. Now let's complete this statement. For any three rational numbers a, b and c, A into B into C, where I associate these two first, is equal to A into B into C, where I associate these two first. Now, so this was our associative property on rational numbers for the operation of multiplication. Now, similarly, we go for the operation of division. So let's quickly get our examples out. So these are three rational numbers: 1 by 2, 3 by 4, 5 by 3. I'm going to insert the division operation in between. So let's zoom in. Okay, divide and divide. Now, how do we solve this expression? There are two ways to do it. First, I'll do the first two. So I'm going to insert the brackets. I'm going to associate these two rational numbers first, and then I will go for 5 by 3, or I'm going to associate the last two, that is 3 by 4 divided by 5 by 3 first, and then we will compare the outputs. So we know how to solve the division between rational numbers. This is basically equal to 1 by 2 into 4 by 3. Okay, we just do the reciprocal of this rational number, which is the denominator in this case, like this divided by this. So the second rational number is done reciprocal, 4 and 3, and we change this operation to multiplication. Similarly, this can be written as multiplied by 3 by 5. Okay, we just do a reciprocal of the denominator, and now this basically becomes similar to the multiplication operation of three rational numbers. So now we go ahead, we multiply the numerators. 1 into 4 is 4, the whole divided by 2 into 3 is 6, multiplied by 3 by 5. Once again, just multiply the numerators and the denominators. So 4 into 3 is 12, and 6 into 5 is 30. So 12 by 30 is the answer here. Now let's come to this side of our association, where we are associated second and third rational number. Now first, what we do is 1 by 2 divided by, so this will be 3 by 4 multiplied by 3 by 5. Okay, that's equal to 1 by 2 divided by, so 3 into 3 9, 4 into 5 is 20, and then once again 1 by 2 multiplied by, flip, take a reciprocal of this, so that becomes 20 by 9. Okay, and now you just multiply the numerators and the denominators. So 1 into 20 is 20, and 2 into 9 is 18, so we get 20 by 18. So very clearly we can see that the output that we get, 12 by 30 and 20 by 18, are exactly different for this different associations. Thus, when it comes to division operation for rational numbers, we say that division is not associative. Let's come here. Yes. So this is our conclusion, that division is not associative. That is, for any three rational numbers, any three random rational numbers a, b and c, we can now say that a divided by b divided by c, where I associate these two first, is not equal to a divided by b divided by c, where I associate these two first. Thus, division is not associative for rational numbers. So in conclusion, we saw that addition is associative, multiplication is associative, and subtraction and division is not associative when it comes to rational numbers.